So now we're on problem 9. And I see 20x in the numerator and the square root of 5x squared in the denominator. Now, I've said this before, I'm a fan of reducing as we go. So the square root of x squared, I want to go ahead and take care of that. So I've got 20x divided by x times the square root of 5. Now, what happens here, you can go ahead and you can put a little cross through these. The x in the numerator and denominator are going to cancel out to where I've just got 20 divided by the square root of 5. Now again, I cannot put that 20 underneath the square root because it's not under a square root itself. So really, all I've got here is, right down here, 20 divided by the square root of 5. Now I'm just going to rationalize my denominator, multiply it by the square root of 5 over the square root of 5, and I get 20 times the square root of 5 in the numerator, 5 in the denominator. 20 divided by 5 will reduce to 4 times the square root of 5. Problem 10. We've got 3 times the square root of 10 in the numerator divided by the square root of 6 in the denominator. Now, I can go ahead and write that as 3 times the square root of 10 divided by 6, all under one square root. Now what that reduces to, 10 over 6 is the same as 5 over 3. Now that did help make it smaller. That step might not be necessary depending on the order you did things, but for me when I'm working without a calculator, it makes me have the ability to work with smaller numbers. Now at this point I'm going to have to split it back up again. So I'm going to have 3 times the square root of 5 up in the numerator, and I'm going to have the square root of 3 down in the denominator. Need to rationalize my denominator, multiply by the square root of 3 over the square root of 3. Now up in the top here, the square root of 5 times the square root of 3, we multiply those numbers, and we would have the square root of 15. Down at the bottom, the square root of 3 times the square root of 3 is 3. And I have some canceling out I can do with my 3's, and I'm left with the square root of 15 as my final answer. Number 11. Square root of 8 divided by 3. Nothing I can do to simplify here, so I'm just going to separate these into the square root of 8 divided by the square root of 3. Go ahead and multiply square root of 3 times the square root of, the square root of 3 divided by the square root of 3. And up at the top we have the square root of 24, and the bottom we have 3. Now the square root of 24, that's the same as square root of 4 times 6. Which, when I go ahead and reduce that, I can take out a 2. And I have 2 times the square root of 6 in my numerator, divided by 3 in my denominator. Last one on this video, I've got number 12. Now this is the first one we've come across that has a cube root that we're going to have to rationalize. So we've got the cube root of 3 in the denominator. Now again, the whole point of rationalizing a denominator is to get rid of your radical. Now, when we have a cube root, we need to multiply by something that's going to have an exponent that'll match this. What I mean by that, we want to have the cube root of 3 cubed. when we do that, we can go ahead and reduce it. So when I'm going to multiply, I'm going to multiply by the cube root. Here, this is kind of like 3 to the first power. I'm going to multiply by the cube root of 3 squared. Reason being, whenever I multiply by that, when I multiply straight across, I'm going to end up with the cube root of 3 to the third, which will reduce. Now again, if I multiply something by the denominator, I have to do the same thing up at the top. So I've got the cube root of 3 squared up there. Now there's nothing I'm going to be able to combine up at the top. So I've got 6 times the cube root of 3 squared up at the top. Now I can go ahead and do a little bit of simplifying. Well, up at the top, I'm going to have 6 times the cube root of 9. No reducing I can do there. Cube root of 3 cubed is going to be 3. 6 divided by 3 reduces down to 2. And I got 2 times the cube root of 9.